Now let's move on. We got some timing components here. I've got these pins. So these are the original pins that would go here. So these thread in here, and then the original guides were sitting here like this, right? And that's all well and good, but with the extra pressure from the chain, right? Because the chain is pressing down on this the whole time. So it's trying to push this over, and there's a lot of pressure here because as the crankshaft is, let's see, the crankshaft's gonna be rotating this way. So it is pulling down onto this. It'll try and snap this pin. Now, not a big deal on a factory motor. Not a big deal at all. But now we're talking about things that need to be upgraded because of the compounding issue. So the original, right? The new one. So this one is much larger. We're gonna have to tap that hole out for it. I'm gonna try and tap it with just the tap. I think it'll work. I don't know, I can't remember how I did this the first time. I don't have a tap guide either, so I'm going to have to do this very, very, nope, I have to drill it. All right, so I will be drilling these out, and that's gonna be pretty fun. I just gotta be really careful and really straight. All right, so that's that. And I'm gonna work on that tonight. Hopefully I can get that done and get those put in straight. That's the goal. I do have a pretty good eye though, so I'm pretty confident. I mean, I did it before on another motor and I did it right. I can't remember what I did it with, but maybe I did it with just my laser eyes. All right, I digress. So these are our new timing guides, and then these are, we have to swap these guide slides. Oh, what are they called? Anyway, the chain thing. We gotta move these over to these. So before we talk about that, let's talk about the heads. So we got the heads back from the machine shop. And they look really good. Nothing exciting going on here. This is basically a factory head that's been rebuilt. So I'm really, really excited to see what we can do with the factory head setup. That's kind of the whole goal I was wanting to do. I'm still seeing how far we can push stock heads, which isn't a new experiment. You know, countless builders and people have done a bunch of stuff with stock heads and whatever. So, but we're just having fun. So the problem we had with the last build I did was power always stopped at like 6,000 RPMs. And naturally aspirated, it did okay. But once I got to 6,000 RPMs, every single time it died out. No matter how much boost I was putting on it, no matter how much nitrous I threw at it, 6,000 RPMs, it just peaked. Which to me is a valve control issue. So what I think was happening was the valves were spinning to a certain, RPM, and then when it got to that max RPM, the valves started to bounce. And if you ever watch a high-speed video of valve train, it's really cool what you'll see. So you've got the cams pressing down on the valves, and when the valve, hold on, I'm adjusting you guys. When the valve tries to return, with the spring, the valve basically hits the seat and bounces. So it just, and when that happens, when the valve's bouncing, that's timing that the valve cannot hold pressure in the combustion chamber, right? So when the valve starts bouncing, pressure is escaping back into the intake system, or the exhaust, and you're not capturing it in the combustion chamber. So that's when you start to lose valve control. And then, so now we're going to talk about the compound issue. So why did I switch out the springs in the heads? The problem is we're going to be running a lot of boost on this. I think the car is probably going to make somewhere between 18 and 20 pounds of boost. That seems like a lot of boost, because it is. But it's not a lot in terms of airflow on this motor. If you put 20 pounds of boost on a Coyote, you'd be insane numbers, right? Way up there in numbers. And it's because your CFM, cubic feet a minute, is much higher on those heads. These heads are quite restrictive in comparison. So that being the case, 20 pounds of boost on this engine is not the same as 20 pounds of boost on a Coyote. It's a completely different thing. Coyotes would make so much more power. Again, I'm doing the 4.6 just because I like to make my life difficult for myself. Not really. It's just an experiment. We're having fun. So it's a set of regular B heads, right? So we have the B head ports. Nothing special, just, you know, nothing special. No port job, no nothing, man. These are just bare casted heads. Looks good. I could do a port job on these for fun. Like I really could get in there and start doing it. I just don't have the tooling for it right now, and I kind of just want my engine to be back together. So I'm just gonna see what we can do with the stock flow rate. And then also stock cams. So that's another space that I probably could invest more money, make more power. Maybe we'll do that later. It's whatever. The change I did make on this head though was the springs, like I said. So the reason, okay, boost, back to the boost. If I've got 18 to 20 pounds of boost pressure in the intake, right? That is 18 to 20 pounds of pressure on the backside of this valve, which is directly played against the spring. So if the spring is seeing that boost pressure, let's say the spring's rated for 130 pounds. Now Ford's not gonna put a high pressure spring on a stock head because Ford's trying to get the highest level of efficiency as possible for what it's designed to do. And it's designed to do 6,500 RPMs naturally aspirated, making 290 horsepower. That's what it's designed to do. We're not asking it to do that. We're doing a lot more. So our design for the head is a little bit different, or the need for the spring is a little bit different. So again, the Ford version of it didn't want to put a high pressure spring in there because now you're asking it to fight. It adds mechanical load to the engine's rotating capabilities. So anything mechanical load on the engine is less horsepower. That's a minus. So anytime you add in the mechanical load in the equation of how much horsepower your car is going to make, you lose horsepower. So they put the least pressure on the springs as possible while also maintaining valve control to run the car to the correct RPM for the heads and cam combo to make power. So because we are adding a bunch of boost pressure, now that 130 pounds is now like 110 pounds if we have 20 pounds of boost pressure behind it. Theoretically, that's what it would, but essentially that's exactly what's happening, right? You've got boost pressure behind the intake valve and it's causing it to you know, fight its way to close itself and seal on the valve seat. So what I did is I found springs that are 25 pounds heavier. So now the spring pressure is quite a bit higher, and we should maintain valve control even with having the extra boost pressure behind the intake valve. Now, in doing that, here's ready where our combo of things start happening. When I add the extra pressure on the valves and on the cams, because that mechanical energy or mechanical load is now placed into the camshaft, which is the cam gear, that directly relates to, it follows down the line down to the crankshaft snout. Because this crankshaft snout is what's rotating all of this. So any type of mechanical load I put anywhere on the engine travels through each component back to what's driving it, which is our crankshaft pulley in this case. So after it goes through the cam sprocket and the cam gear, it transfers itself into the timing chain. So I made sure to get a good Ford Racing timing chain. Want something that's going to work well for us. So then it transfers itself into the timing chain, and the timing chain is riding on our guides. So if I have the stock guides in here, and some of the stock guides used to have a mounting on some of the blocks, the mounting hole would be like, I can't remember exactly where it is, but basically it would be, yeah, I think this is, no, maybe this is it? I can't remember. When I start putting it together, I'll remember where everything goes. But long story short, this hole wasn't here, this bolt. So what would happen, it was bolted up here. You had this whole section down here, and it would actually, from the pressure of the chain, snap off the end of the guide. And when it didn't, you know, you're ending up with failure. So that being the case, we, you know, got some nice, bigger, stronger guides. And we also have the extra pins because, again, spring pressure through the cam, through the sprockets, into the chain, being held onto by the timing guides, and then driven by the crankshaft snout and the crank gear.